All right. Any question or homework question? Please let me know. No? No? Aiden, do you have any questions? Okay. You gotta make sure you get it. Okay. All right. So today's stuff is gonna be kind of hard because we didn't teach this last year. So I could have spent a week teaching about this topic where most of the students not able to get it, and just for one multiple choice question is not really worth it. But this year we have to know what a sigma is. So it's not sigma bond. It's not chemistry. Okay, so. Oh, sorry. All right, guys. Okay, so I will talk about it. So this is called sigma notation. So this is the first time you see this, or sometimes in competition using this. Is A1. This means AI. So this means A1 plus A2.
This is something I read on like the
And then say plus A2 twice.
A3, sorry. All right, so and it's basically just adding each thing. So we're gonna talk about what does this mean. This means the lower bound, kind of like the integral. There's a lower bound, and this is the upper bound. This is where you stop. Okay. So I'll give you an example. That's really easy example. It's gonna be summation. This is also known as sigma or called summation. If I equal to 1, and this is 100. So what does that mean? That means this I stand for integers, and it has to be whole number. It has to continue on 1, 2, 3, 4, 5, 6, 7, 8. So this just means is 1 plus 2 plus 3 dot 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 plus 98 plus 99 plus 100, all the way to stop at 100, because your upper bound stop at 100, your lower bound start at 1, and you just plug in the I equal to, the I stand for integers, so it does not have fractions, does not have 1.1 or 1.2, it's just 1, 2, 3, 4, and you plug in the I. Now if it's I squared, then it's going to be 1 squared plus 2 squared plus 3 squared plus 4 squared all the way to 100. Yes.
So like, how do I know like the intervals of it? 'Cause let's say like it was an integer, or is it just always an integer?
It's always integer.
So like summations would never be used for like that.
Yeah, it's the I equal to 1, I equal to 2, I equal to 3. That's always integers. Yes. You will plug in this 1 into here, and you plug in the next number, which is 2, plug in I. And plug in 3, plug in I. Plug in 4, plug in I. Yes,
It
Brendan?
always includes the lower and upper bound.
It's always inclusive, the lower bound and upper bound, but depends on the questions. Okay, so sometimes the question started lower bound at 2, then you start at 2.
It's like we're back.
Yeah, inclusive. If you guys have question, Armin, Ethan, if you have question, ask me. If you have question, just raise your hand because I cannot answer I cannot talk over you guys. I don't have voice. So if today I say, hey, summation of I equal to 2 and start at 5, and that just says I squared minus 3. What does that mean? This means you had to plug in 2. You start at 2, 2 squared minus 3, plus 3 squared minus 3, plus 4 squared minus 3, and a plus 5 squared minus 3. Does that make sense? I just plug in the numbers starting at 2 and at 5. At this case, it will be 1 plus, I think, 6 plus 13 plus 22, which is, I have no idea what that is. So 7, 20, 42. Okay, 42. So that'll be 42. Now let's talk about property. So property of sigma notation. Okay. So what is a property? The property, basic, very easy property is if you have a k to the a I n equal to 1, and this is sorry, this is I equal to 1, and so basically k can be taken outside because it's a constant. I equal to 1 n of a1. So that's one of the property. So that means if you have constant, just like a limit or derivative or integration, you can take it outside completely.
What do you do with the k after? You multiply it by your final equation, or you multiply it by
Yeah.
your final?
So let's say if today let's just say this is 2, right? Or let's say 2 like this. You can take a 2 out, and it's 2, so it'll be 2 times this will be 84. So it'll be 2 times the whole thing together, summation all together, and multiply by 2. Yes. Because the upper bound is 5. So that's where you know when to stop. Okay. So let's just say if today is I equal to 1 of n of ai plus minus bi. So you can break the two separate things. You can break the two separate things. So that's going to be I equal to 1 n of ai plus minus summation of I equal to 1 of n plus bi. So those are two properties, just like kind of like integral. If you integrate something, you can break it to 2 part, or derivative, you can break it to 2 part. Summation can also break to 2 part. Yes.
We do the same. You know how like integrals, we would have like find the integral from like 2 to 3 if we know it from like 2 to 5. Like you can split it that way. Like
No, I think what I'm trying to say is like integration of x squared plus x dx. It can be integration of x plus
oh
plus
yeah,
x.
yeah, yeah. I mean like does that
Like
mean we can
this.
also do that. Like, you know from one bound to the other bound or from A to B, B to C. Or B to A.
You can, but that's not one of the things that we need because we usually is from one bound to the other bound. We don't need to break the two separate bounds here. Okay, so so that's property. Let's talk about summation formula, and let's go back revisit this question. Do you guys know the answer for 1 plus 2 plus 3 plus 98 all the way plus to 98, 99, 100? It's not exclamation mark. It's not 100 factorial. What?
8, but it'd be 5,000.
Almost. Very close to 5,000. So, there is a mathematician. His name is Patrick Gauss. If anybody's name you need to know, it'll be like, for calculus, at least Isaac Newton, Gottfried Leibniz is the implicit derivative. I'll have to, yeah, that'll be a good one. Lagrange is the one that involved the mean value theorem. Is Lagrange? Yes. This one is. Dude, let me talk. This one is actually Frederick Gauss. So Frederick Gauss. And let me see how to spell it. Fried Dricchgauss. Frederick Gauss is the inventor of. They call him the father of algebra. He's the one that really come up with algebra and really able to do a lot of math stuff, including fundamental theorem of algebra, which is if x to the cube plus x, there's 3 solutions because cube, there's 3 solutions. He says that because he's actually the person that written the idea of that. He's also have major contribution in physics. Gauss is a person that who come up with the Gauss's law, which is the Gauss's law is the how much the wire, how thick the wire is can conduct how much electricity. So he invented Gauss's law. He does a lot of major contribution, but when he was 8 years old, like, yeah, he's really smart. He was 8-year-old. He's like always causing trouble. So his teacher says, "Can you just sit down?" He says, "Well, can you give me something to do? Then I'll sit down. I'll do it." And so his teacher said, "Just add 1 plus 2 plus 3 plus 4 plus 5 all the way to 100." And he come back to the teacher. He actually has a movie now about this guy. I forgot what's the name of the movie. I saw it the other day. So he come back in a few moments later. It was like a couple minutes later. He come back. The answer was 50-50. So 5,050. So, so the teacher didn't believe him. The teacher says, "Wait, you come up with answer. There's no way this answer is right." So his teacher add up every single number. 20 minutes later, he finally got an answer 50-50. Which is this guy, he's 8 years old, he found out 50-50, he found out for a reason. So he come up with a summation formula, which is we're going to talk about it right now. But his idea is take this, and you say, okay, well, take the first term, add it to the last term. And then take the last term to add it to the second last term. And take the third term to this. And then eventually it's going to be all the way to 50 plus 51. So this is all 101, this is all 101, and this is all 101, and this is all 101. So it'll be actually 101 times 50. So that's equal to 50-50. So the answer is 50-50. And he come up with this at 8 years old. Very bright child. Phenomenal kid. Oh, he's dead, but yeah.
Wait, go back, please.
50 plus 51.
Yeah, it's 50 plus 1. Oh, I thought it was 50 plus 1. At least 2.
No, you could not. I love you. Yo, you'd be like a month in a room and I could have come up with that 2 days. A month in a room.
All right. Shh. So what he did is there is a series of formula. I need you to write it down because you're gonna have to need it for homework. So this is the first formula you come up with is summation of I equal to 1 and it's going to n to the c is equal to cn. And I'll give you an example of this. So example is, what if you have summation of I equal to 1 to the 6 and this one is just 3. So obviously there's no number I can plug in. I cannot plug in 1, 2, 3, 4, 5, 6, but it still has a term number. So this is the same thing as equate to 3 plus 3 plus 3 plus 3 plus 3 plus 3 is equal to 18, I believe. Yeah. So it's equal to 18. Or it's equal to, according to this question, is C, which is 3, times the n, which is 6, which is 18 also, using the formula, which is Cn. And this one's fairly easy. The second one is a summation. This one we're going to use a lot. I equal to 1. And I is equal to n times m plus 1 over 2. So this is what Gauss discovered. Remember, Gauss said, if you have summation of I equal to 1 of 100 of I, well, we know the n is the last term, which is 100, right? Over 2 times m plus 1 is 100 plus 1. It's same thing what we got because of 50 times 101. So he come up this formula at age of 8. So that's why he's like super smart. Remind you of Brendan? All right. I equal to 1. So what happened is you got I squared as well. I squared is equal to, now I don't know how this formula come in play, but you're pretty sure you can YouTube it and they will teach you the proof. And I'm too lazy to look it up, so don't ask me. So I'd rather tell you I don't know. Then this is the formula for if the I squared, summation of I squared of 1 to the n. There is another one, summation of I equal to 1 and of I to the cube. And there's a reason why I didn't teach this last year, because I know that this is kind of confusing, but we need a sigma for the notation later, so I'd rather teach it now for BC. Yeah, so that's why you plug in you just plug in the equation. You don't have to do the work. So let's just say if I have, let's just say today if I have I equal to 1 of n, that says n is equal start by 4. That's something we can manage, right? So be 1 to the cube plus 2 to the cube plus 3 to the cube plus 4 to the cube, right? Or we can use this formula, which is 4 squared times 4 plus 1 squared over 4, which is this 4 gonna cancel out. It's gonna be 4 times 5 squared, which is 100. So what's this one is 1 plus 8 plus 27 plus 64. What would it be? Is 99 plus 9, so it's 100. So yeah, you can use the equation. Super easy. You just had to plug in the equation. But the thing is,
know whatever it's asking for squared and cubed.
They will tell you. So today, if I say, this question says summation of, oh, I mean, this one's I to the Q, sorry. If summation I to the Q, I forgot to write down I to the Q. So IQ, I can use that equation. I square, I can use the other equation. I can use the first equation. What?
Like the real world.
We're gonna get to there. It's not real world. It's how you find the integral using this way. Yeah, it's called definition integral. Remember last year when you take an AP exam, there's one question that you said, Mr. Yin, you never teaching us. And I'm like, I'm not spending 4 days of my life teach you, and you're still gonna get it wrong. So I'm gonna spend it on the BC calculus when I have a group of super bright kids. Not saying like before it's not super bright kids, but before those some kid will not. It doesn't matter if I teach 2 weeks or 3 weeks. This year that I can teach you guys 2 days, and you guys should be able to get. Now, okay, so the idea today is understand the idea of summation and understand how to use them. So today, if I say, can you evaluate if n equal to 10 or n equal to 100 or n equal to 1,000 or even n equal to 10,000 of this situation. So this is summation of I equal to 1 and this is I plus 1 over n squared. Now I'm going to write this n squared in a different color. So I'm going to write it as green. So remember, the things I can plug in is only in the I, right? So that means n squared is a constant. Is this okay? So the constant can be taken outside due to the property says 1 over n squared. Very, very important. 1 over n squared times summation. Now, this is summation of two summations here. This one is going to be summation of I equal to 1 of n of I plus summation of I equal to 1 of n to the 1. Now remember, we can go back, copy the formula. What's summation of I from 1 to infinite, to 1 to n? N times n plus 1 over 2, right? Plus, what's the summation of 1? N times 1, so it'll be n, right? So guess what? Then it will be 1 over n squared. And then I'm going to add those two first. So it'll be n times, I'm going to distribute this. So it'll be n squared plus n over 2 plus n2 over 2. Which is left with the 1 over n squared times n squared plus 3n over 2. If I factor out the n, cancel out one of them, so it'll be n plus 3 over 2n. And that should be my final answer for this. Now, if I want to find out what 10 is, I can plug in 10. If I want 100, I can plug in 100. Because we come out a general form, I can plug in any number. So I don't need to add up to the first term to the last term. I can say, well, I can just plug in here. It should give me a formula because this is the breakdown of the summation. Yes. Because using this equation here, C times n. So let's just say if I will plug in n is equal to 10 or 100 or 1,000 or 10,000. I'll just plug in and I can use a calculator to do the situation. This one's gonna be the output is summation of I equal to 1 to the n to the m plus 1 over or I plus 1 over n squared. That's equal to 0.65, 0.515. What if I go to larger? What do you think eventually approaching? If I go larger, not 0, not 1 either. Look at the equation, tells me. Look at this equation, what does that reach to? If n approach infinity, 0.5. Because the infinite, right? So this is all the value. So as I'm reaching to infinite amount of piece, it actually plateau into a value because the horizontal tangent or when the limit approaches infinity divided by highest degree of denominator. So if you divide by n top and bottom, then you will get 1 over 2. So that's going to give you 1/2. So you know eventually it's going to go to 1/2.
Oh yeah, it's horizontal.
Okay. Now we're going to talk about how do you find the area under the curve of a function. This is the meat and soul of this. So this is a definition of integral. So this is what we're trying to get to today. This is what we're trying to get to today. So I need you to maintain high focus in this part. And we're going to use definition integral to figure out certain things. So we're going to explain to you what's definition integral first. So integration between a to b of f of x dx can be rewritten as limits as n approach infinite of summation of n I equal to 1, this to infinity, of f of mi, and we're going to talk about mi stand for, and the delta x. Mi delta x. Okay, so it could be mi or could be a non-capitalized mi. So I'm going to say mi stand for right endpoint. And if you have a non-capital I, which is this one's harder, it's left endpoint. Yes. Infinity. Okay, I know this is really confusing. This is the reason why I didn't teach last year. And I was like, well, I'll just leave that to AB, BC, because AB is gonna be like even Aiden this year is not gonna see this. Okay, so if you're in AB, you're not gonna see this. So let's start with the simple part. This is the width of rectangle. It's the width of a rectangle. So this is the width of rectangle. So this is this, okay? Now what is this? What's the other one? Yes, height of rectangle. Height of rectangle, one's width. Now, if I break to infinite amount of pieces and now add them all up, that is gonna be the integral. Okay, so but we're gonna get there first. First, let's define delta x. the delta x is always b minus a over n. Why? B is the upper bound minus the lower bound divided by how many rectangle you want to break up. So let's say between 0 to 2. Give me a second, Josh. Between 0 to 2, if I want to break the two rectangle, will be 2 divided by 2 is 1. So each width is 1. Now, if I say I want to break the four rectangle between 0 to 2, will be 2 minus 0. Like, it'll be like 2 minus 0 over 4. Then each rectangle is 1/2. Does that make sense? So it's always, delta x is always b minus a over n. Yes, Joshua.
My question was, if I always has to be a number, like an integer, then I don't get how you can break it up into infinitely small pieces.
We're gonna get there. Give me a second. Give me a second. Just wait for me. But start by understanding the width first. Wait a second. Now, we're gonna say, what is mi? Mi is a right endpoint. Okay, so mi is gonna be a little bit different. Mi is equal to a. You're gonna be like, why is a gonna do it with here? Well, a is your lower bound. But we're not based on lower bound. If we base on the lower bound, it's gonna be left endpoint. We're gonna base on the right endpoint. So it's gonna be plus, in this case, it's gonna be what? B minus a over n. Now times I. Why times I? Because I is a number that you're gonna break down to, right? You're gonna break to if you want I to go to infinite. So in this case, that we're gonna just do one example. We're gonna come back to answer all the question because I don't want to answer halfway and then not understanding. This is not a long. We have to spend a lot of time to understand. So what we're gonna do is definition of integral is this. Now mi is equal to a plus b minus a over n times I. Now you're gonna say, okay, well, we want to find integration of this question. Great. This question is gonna be, I think my thing just died. So we're gonna say f of x is equal to x squared, and between 0 to 2. So this is a A, this is a B. Is that okay? Now first let's practice drawing this. So if I draw this, it's gonna be here, and it's gonna be 2, 3, 4. It's gonna be right here, I think. Okay, so this is gonna be like this. Now remember, I'm gonna do it in a 4 rectangle right now, and I'm gonna use right endpoint. The right endpoint is we're gonna approximate this area, use right endpoint. So we're gonna base on the right endpoint. So we're gonna do 1. Sorry. 1. My fault. 1, 2, 3, 4. And there's a 4 rectangle. In this case, we're gonna do 4, but we're gonna go back to do here. Okay. So we know integration from 0 to 2 of f of x squared dx is equal to, well, this is f of x dx, so f of x dx is equal to limits as n approach infinity, summation of I equal to 1 to n. Now, in this case, we do 4 rectangle, but ideally we want to go in from 4 to infinite. We want to do infinite. So we says, hey, delta x is equal to what? Let me write down the delta x. Delta x is equal to what? 2 minus 0 over 4. But in this case, we want to go to infinite. So 2 over n. Is that okay? So it depends. If I draw a 100 rectangle, then it's going to be 1 over 50. Is that okay? And so we're going to do f. The a is 0 plus, because start at 0. You're adding the width. What is the width here? 2 over n, right? So 2 over n times by I. Why I? Because I is the partition that you're going to add up. Times 2 over n. So it's 2 over n times I. Now I'm going to go into the next line. I'm going to say limits as n approach infinity, summation I equal to 1. And this is f of 2I over n times 2 over n. What's the f of x here? X squared. So do I plug in 2I over n into x squared? So limit n approach infinity, summation I equal to 1 n. This one's going to be 2I over n squared because the function's x squared. So I plug in this times 2 over n. Now, let's go back. Let's not do it infinity. Let's do it to 4. And let's see what happens if it's to 4. It'll be summation of 2I over 4, right? To the square times 2 over 4, right? And this is a width. So width. That's that. And this is half I squared, right? But that's only is a 4. That's upper bound is 4. So that means I'm going to do 1. I'm plugging 1 here. That means I want to know the height when x equal to half. And then you plug in that, you plug into the x squared. So it's half squared is a 4, 1/4. Is that okay? And times 2 over 4, which is 1/2. So you had to do that. You add up 1, 2, 3, 4. But we don't want to do it to 4. We want to do it to infinite. So we're going to simplify this, which is very, very easy. You will say it's really scary. Well, it's not, because if you know how to simplify your exponent rule, then that's going to give you 8i squared. Total is 8i squared, right? 2i squared times 2, so it's 4i squared. And this one is going to be n squared. Oh, NQ, you're right. Thank you. So NQ. So what can I do? Yes. Because we say f of x equal to x squared, so we're going to plug in the 2i over n into the square. So then you say, what is constant? Do you see this constant? 8 over n cubed. So be limits n approach infinity, 8 over n cubed. Taking out the constant. That's the tricky part. And that's summation I equal to 1 to the n. And this is the I square. I don't want it to leave that is really messy. I just want to focus on I square, because the formula we have is the I square is right here. So we're going to copy this. Okay, so we almost done, surprisingly. So it's equal to limits as n approach infinity, 8 over n cubed. This one is gonna be n times m plus 1 times 2m plus 1 all over 6. Now, I'm almost done, just right here. N approaching infinity. On the top, it's going to be 16, right? N to the third power plus whatever. We don't care whatever term is after that because we divided by highest degrees. You can write that down if you want. 6n to the q. But the bottom's only 6n to the q. So if you reach infinity, it's just going to be 16 over 6, which is 8 over 3.
I can look at just integrate.
You could. You could. But you gotta understand the theory behind it. What? You guys have homework about trig integrals, which is sine, cosine. I'll take a picture and send it to you. We'll do more of this tomorrow.
Yeah. I need those points.
I got you, Riley.
At least 2 points.
Dude, I'm sitting there with Aiden, and I'm like, wait, that's 2 in right. I look up, they get up, and I'm like, where did we get it? Dude, this is horrible. Aiden, it makes sense if you think.
You're always on my brother's whiteboard.
This one?
He was when he was doing health.
It's like my
No, the single sign. It was more like entirely blind.
Yeah. Yeah, it's a Riemann sum.
Oh, yeah, there's like a Riemann somewhere like
It's
85.
a Riemann sum, duh. Just say duh.
Oh, the x squared. Is it for the x squared? Like, I'm like, what the fuck?
He said he was gonna leave it. Oh yeah, he did.
What's it? Like, he looks excited to be in Ken now.
Oh, AJ?
Oh, hey, Ken.
Yeah, I don't think he likes him.
I think he thinks he's smarter than me.
Yeah, I don't really think it's not true, but you know, he can think that.
I definitely am better at coding. Because I have to know kind of coding. He's do more. But he, like, I really asked him, he acknowledged, he shook his head. But I just coded.
Okay.
I read it. I mean, it's a fact. What'd you do?
Huh? Yes.
Yes. Okay.
Harper. Okay, so your test question will show up as this. Mr. Yi is throwing the ball upward at 96 feet per second on top of 256 feet building. And this actually applied to calculus because today they were doing exact same thing, except they had to do the calculus. You guys only had to do the algebra 2, which is nice. I need you to find the height equation, which is you got to write down the height equation based on the notes. Second, I will ask you to find the time when the ball reach maximum height C, I will find the maximum height of the ball. There are two different type of question, by the way. D, I want you to find the time the ball reached the ground. E, I want you to find the average velocity between t equal to 1 and t equal to 3. You don't need a graph table, but it starts with this question that you will see on your test. Huh? D? C says find the maximum height of the ball. Yes. Okay, which one you cannot read? I'll read it to you. Huh? It says Mr. Yi is throwing a ball upward at 96 feet per second on top of 256 feet building. And you gotta write a height equation based on a projectile function. Second, I want you to find a time when the ball reached maximum height. So, and the Varan, you had to do it in calculus. They have to do it in algebra. Okay, C is find the maximum height of the ball. D is find the time when the ball reach the ground. So when they hit the ground. And find the velocity. Can somebody get a door for Matt?
I got it.
Okay.
No passing.
Hey, can you move it up slightly?
This is how the test is gonna look like. Your test is gonna be on Thursday. Everything in quadratic. Everything absolute value. Even today we're gonna go through some quadratic formulas. Make sure you know how to do quadratic formula. A lot of you guys need to know how to do quadratic formula. It should not be no big deal because you learn that in algebra 2. So go back, look at your notes, how to write a height equation.
Did you have any questions about the stuff we learned today in class?
Actually, there's one here for pre-calc too, but you guys gonna find different things. So you guys are finding the velocity hit the ground, and that's a little bit different.
Yeah.
And yeah, I think the same thing, except you have to find the velocity when the ball hit the ground.
Down to got it.
Yeah.
Thank you.
Straight, why are we doing negative?
Arthur, why don't you shut the hell up and get to work? Somebody make me a cake. Book, Book and Aiden. They made me wear an eye patch and a ping pong table.
Wait. It says find the maximum height and then find the maximum. It says find
The first one is to find the time when the ball reached maximum height. The C is to find the maximum height of the ball.
Where are you?
Don't use negative 9.8 because that's the physics. I want you to use the calculus, use the math one, which is the G is a half of 32.
Is that 256 per building?
Yes, 256 feet building.
Five, eight. Yeah, I don't care. Wait, he factored out.
Okay, this is only for calculus. You don't have to worry about this. For pre-calculus, you don't have, because for calculus have an extra part. For pre-calculus, you don't. You stop at a part E. In calculus, is gonna be a different way of doing things. So
Isn't it going? Isn't if it's negative? No, I know what you mean. Sorry. Go. Let's say one is.
Oh, we made it smaller.
So this is better than. For converting this one is this one. No, yeah, that's all we do. But we need to get 16.
I already told you this question to be on the test. Maybe different numbers. You don't want to use the 9.8 meter per second. You want to use negative 32 feet per second square because it will be easier for this particular question.
I thought it was negative 16.
Yeah, it's a half of GT squared, so it's half of negative 32.
Wait, so am I canceling?
Alexis, what do you need?
That would be the.
F you don't need to do, F only for calculus students.
Oh.
F you need to find the velocity at when it hit the ground, it need a calculus to do it. You cannot use a algebra 2 to get it. You can use kinematic from physics, but you don't have those equations either. So yeah. B says find the time when the ball reached maximum height,
It's on the back.
which is you're looking for something in the quadratic.